Segments. This is section 1-2 and 1-3. The essential question. This is the question that you'll be able to answer at the end. What are congruent segments? A postulate or an axiom is a rule that is accepted without proof. Postulate, axiom. They both mean the same. A theorem is a true statement that follows as a result of other true statements. So the postulate and the axiom you have to just accept without proof. A theorem you would have to prove. Your first postulate is ruler postulate. Basically what it is it's like a number line. You have numbers, real numbers on a number line, and points that correlate to that. We call them coordinates that correspond to the real numbers. The distance between those 2 points is written as the absolute value of the difference of the coordinates. So the distance is also known as measure, is between the 2 points. So let's just pretend this frog jumping on our number line, we want to find the distance between those real numbers 5 and 9. So we're going to label 5 as A, so that's point A. 9 is point B. We want to find the length or the distance between those two. So we take the x-coordinate B minus the x-coordinate A. The reason why we're saying x is because it's a horizontal line. If we had a vertical line, we would say y2 minus y1. So we would find the length between A and B. Now we're using the absolute value because we're dealing with measures. So you'll never have a negative measure. So now you can just take 9 minus 5, which is 4, or you can just count like a frog jumping. 1, 2, 3, 4 from A to B. So the measure of AB is 4. Now segment addition postulate is your second postulate that you're going to learn for today, and it is a very well-known postulate. This is going to help you set up equations. If B is between A and C, then the line segment AB plus the line segment BC is going to equal the whole entire line segment AC. Now we can also write this backwards. If AB plus BC, equals AC, then B is between A and C. So let's look at a line segment. Point A, point B, and point C. Pretend those points are all on the line segment. Kind of hard to draw on a computer. If I take line segment AB and I add connecting to it line segment BC, it's going to give me the whole line segment AC. It's just like connecting Legos. You have one Lego, you connect another Lego to it, and you get a whole longer Lego. So let's look at it with actual measures. We're going to find XZ, the length of XZ. So notice Y is between X and Z. So we're going to add XY and YZ together using the segment addition postulate. XY plus YZ equals XZ. Now let's go ahead and substitute the numbers in. 4 5/8 plus 2 1/2 will give us the whole line segment XZ. So you have 7 1/8. Now this one you're going to do on your own. So if you need to, please stop this presentation so you can take a moment, because in just a few minutes I'm going to be moving on. Okay, so now hopefully you did VW plus WX equals VX, since W is between V and X. So now I would take 37 plus the unknown WX to equal the whole thing VX. And of course you subtract. So therefore you get WX is 107. Congruent segments is another way to set up equations. Look at line segment DE and line segment FG. Notice they have little red tick marks on them. That represent that they are congruent to each other or the same measure. They each have to have the same tick marks when we're talking about line segments. If I had 2 tick marks on DE, then I must have 2 tick marks on FG. Or 3 tick marks on DE, then FG should also have 3 tick marks. They have to have the same amount of tick marks to be congruent or equal. Like I said, line segments that have the same length are called congruent segments. Now there is a symbol for congruent. Whenever we write a congruent statement, notice the line segments have their notation on top. DE with the line segment on top of it, and FG with the line segment on top of it. And in between you see an equal with a squiggly. That equal with the squiggly means congruent. So DE is congruent to FG. But that also means that they are equal to each other. Now, whenever we use the symbol equal and not congruent, we no longer need that line segment bar. The reason why is because we're dealing with measure. And measure is always going to be a line segment because we cannot sit there and measure a line. So DE is equal to FG. We use the equal sign whenever we're going to set up mathematical equations. We use the congruent symbol when we're writing congruent statements. Now look at this snowboard. It has a line segment XY, and T is on XY. It's between it. We also have a line segment VW with T between it, and they are intersecting each other at T. Notice the red tick marks from X to T and T to Y. That T, therefore, is the midpoint. Whenever you have a point on a line segment creating 2 congruent tick marks, it's creating 2 congruent segments, with T being the middle. Remember again, these 3 points are collinear, and T is the midpoint of those 3 points. So since T is the midpoint of XY, we can therefore state that XT is congruent to TY, or if we're using algebra, we would say XT is equal to TY. So whenever you see midpoint, you know to set them equal to each other when you're dealing with line segments. Now here comes a line LM. Notice it's intersecting XY at that midpoint T. It's also intersecting the line segment VW at that point T. These are known as segment bisectors. Bisector means it's bisecting it directly in half in the middle, cutting it into 2 equal parts. So VW is a segment bisector. Line LM is a segment bisector. Also, a plane can be a segment bisector as well as a ray. It always hits the midpoint, and it always only bisects a line segment. It cannot bisect a ray, a plane, or a line. Same thing though, whenever you see the term segment bisector, you know then that xt is equal to ty or xt is congruent to ty. Now this problem you will have to do on your own. Either use graph paper or make a crude graph, an xy coordinate graph on your paper. Plot the points for A and B, plot the points for C and D, and count the line segments. Count them, just like the frog, or take the absolute value, because these are horizontal and vertical lines, and determine whether or not they have the same measure. That is, are they congruent? Either stop the slide now to do this, or I will take a few minutes and then we will move on. If you're having trouble graphing, remember you start at the origin 0, 0, and for A you would go to the left 2 units and then up 4 units and plot the point. For B you would start at the origin 0, 0, and then move to the right 3 units and then move up 4 units, plot the point, and then connect A to B. For C, you would start at the origin 0, 0. You would not move right or left because it's at 0. You would move up 2. For D, you would start at the origin at 0, 0. You would not move left or right since it's at 0, and you would move down 2 units. Then you would connect C and D. Now count from A to B and count from C to D, or use the absolute value. For A to B, you would use the x coordinates. For C to D, you would use the y coordinates. Are they congruent? No. No, they're not. One is 5 units, one is 4 units. Okay, here comes an algebra problem. Now this one, instead of a word problem mentioning just the word midpoint or just mentioning segment bisector, I've also drawn you a picture. Notice the red tick marks. It also states that M is the midpoint, so it's directly in the middle. So therefore, algebraically, we know that VM is congruent to MW. Or we know VM is equal to MW. Now see if you can solve this algebraically. Substitute for VM 4x minus 1 and substitute in for MW 3x plus 3. Stop the slide if you need to work this out, or work with me. I will continue in a few minutes. Okay, so we're going to first write the equation. VM is equal to MW because we know that M is the midpoint. Now substitute the information in. 4x minus 1 gets substituted for VM. 3x plus 3 gets substituted for MW. Now I like to subtract my variables first. So I'm going to subtract 3x from each side. I end up with x minus 1 equals 3. Now we're going to add 1 to each side, and we get x equals 4. Now I hope when you did this on your own, you did not stop here, because that is not our solution. X equals 4, not the length of VM. The length of VM is 4 times something minus 1. Now we have that something. So we're going to have to substitute the 4 in for x. So VM, remember, was 4x minus 1. So we substitute 4 in for x, and we get 4 times 4 minus 1. So that'd be 16 minus 1, which is 15. So the length of VM is 15. Now remember, we said that M was the midpoint. So you can check your answer, because if you substitute 4 in for the other statement, 3x plus 3, it also should come out to be 15, because they are supposed to be equal. So MW does equal 15, because we get 12 plus 3 is 15. So therefore, it is correct. Now, another thing that you could do is, what if instead now I want VW? Well, if I want VW, you can use the segment addition postulate. We know VM is 15. We know MW is 15. So now we can add 15 plus 15. So VW is 30. Okay, moving away from line segments. Well, actually, we're still going to do line segments, but now we're going to look at it on a coordinate grid. And we're going to use two formulas, midpoint formula and distance formula. First, let's look at the midpoint formula. The midpoint formula is the average of the x-coordinates, and it's the average of the y-coordinates. Now remember, for x-coordinates, you only have two numbers, so you're adding two numbers and dividing by 2. For the y-coordinates, you only have two numbers, so you're adding the two coordinates together and dividing by 2. So x1 plus x2 over 2 and y1 plus y2 over 2. Notice there's a comma in between because you get a new coordinate, not a measure, just a placement on the graph. So let's go back to that picture that we started with. We're going to find the midpoint of R to J. We want to find what exactly is directly in the middle of RJ. Now, if this was a horizontal or vertical line, it's easier to find, but it's not. So therefore, we have to use the midpoint formula. Now we're going to look at the R coordinates. The R's X coordinate is 5, and the R's Y coordinate is 3. Now J's X coordinate is 10, and J's Y coordinate is 8. It's up to you which one you make your x1, y1, and your x2, y2. I do believe I made R's x1, y1, and J's x2, y2. So I'm going to substitute it into the formula. So 5 plus 10, the average, which means over 2, comma, 3 plus 8 over 2. Now we just simplify. We take 5 plus 10, which is 15, and 8 plus 3, which is 11. So our answer, because it cannot be reduced, is 15 halves and 11 halves. You could always change these to decimals, as well as make them into mixed fractions. So that is our midpoint from R to J. Now the distance formula is another formula on a coordinate grid. It also uses two coordinates. It is the measure between two endpoints. Now, when we had it before on the coordinate, when you had to determine that one example, whether or not they were congruent, that was a horizontal and a vertical line. So always you can just count the spaces or use the absolute value. But with when you have two coordinates that make it a diagonal, you cannot. So we're going to use the two coordinates again, x1, y1, and x2, y2. This time we'll use this formula. It stands for the distance equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. We simplify everything, and that will give us our measure. So let's look back at this example. This time we're going to find the measure from R to J, or R to K, I apologize. Find the length of R to K. Now I'm going to make my r x1, y1, and I'm going to make my k x2, y2. But it's totally up to you which one you make, x1, y1, or x2, y2. So here's our formula. I substituted in for x2 my 6, my x1 my 5, the other coordinate. I substituted in the 7 for my y2 and the 3 for my y1. Now I'm going to do order of operations, so I must do parentheses first. So when I take 6 minus 5, I get 1. When I take 7 minus 3, I get 4. Now we're going to do exponents next. So 1 times 1 and 4 times 4. So 1 plus 16, and then we add, and we get the square root of 17. Now you can leave it as the square root of 17 because it cannot be simplified, or you may change it to a decimal, whatever it asks of you. Now, Pythagorean theorem, I'm sure you've heard of that. We'll use it again, especially when we get into right triangles. Actually, the distance formula is derived from the Pythagorean theorem. So it too can be used on a coordinate graph if you prefer. The formula for the Pythagorean theorem, remember, is the hypotenuse squared equals the sum of the legs squared. So therefore, c squared equals a squared plus b squared. Now, if we were to square root both sides, the c squared becomes c, and the a squared plus b squared is the square root of a squared plus b squared. So see, it's very similar to the distance formula. So now what we're going to do is we're going to use the Pythagorean theorem, finding the length of r to j. I drew a line segment from r to j because when you want to use the Pythagorean theorem on a coordinate grid, you must draw a right triangle. So I'm going to draw a horizontal line starting at r and going towards the right, and I'm going to draw a line segment from j going down until they intersect. And where they intersect when I do that is at I made L. Now we're going to find the distance from R to L. Now remember, to do that, you can either count the distance or you can use the absolute value because it is a horizontal line. So I count the distance and I have 5. I'm going to do the same thing for L to J or J to L. And when I do that, I get 5. Now I'm going to go ahead and do the Pythagorean theorem to find Rj. So I'm going to substitute it in. Now it makes no difference which one you make your A or which one you make your B, but Rj is always your C. The diagonal is always your C. So we have the absolute value of 5 squared plus 5 squared. Simplify. 25 plus 25, we get square root of 50. Now the square root of 50 can be simplified, and if you forgot how to simplify your radicals, we will work on that in class. This comes out to be 2 square root of 5 because there are 2 25s when you multiply. So therefore, we get 2 square root of 5, or you can change it to a decimal. Okay, now this is our last one for today, our last slide. We will practice this in class using everything that you have learned. Also, I'll be asking you to answer the essential question. I hope you have a great day, and I'll see you later.